This is the Building Automation Monthly Podcast with Phil Zito, episode 88. Hey folks, Phil Zito here, and welcome to the Building Automation Monthly Podcast. In this episode, we're finalizing the three-part series on creating building automation system designs. And this episode is titled The 7 Outputs of the BAS Design Process. And as you can probably guess what we're going to cover, the 7 outputs of the BAS design process. If you haven't listened to episodes 86 and 87, no big deal. After this episode, I encourage you to go back and listen to those because that will kind of fill in the gaps around the inputs and the design process itself. But I'll give you a quick recap. So basically, back in episode 86, we went through the design inputs. So what do you need to create a building automation system design? And we went through that there are essentially 6 design inputs, and 3 of those design inputs you'll have on almost every project. And those are the MEP plans, so those are the mechanical, electrical, and plumbing plans, specifications, and scope of work documents. Then we discussed how on certain retrofit projects, you'll go and potentially have existing construction documents, existing control drawings, and customer interviews and site walks. Now, we went through each one of those in much greater detail than we have time to do in this episode. So if you want to learn about those design inputs, I really encourage you to go back and listen to episode 86. Then in the following episode, we went into covering the design lifecycle, and that was episode 87. And that's where we went through initiating, creating, modifying, and closing, the 4 phases of the design lifecycle. Essentially, you start your design through the initiating phase. You then create your design during the creating phase. You modify your design based on any feedback, any rejected submittals, etc. during the modifying phase. And finally, then you close out your design and produce a set of closeout documents, also often known as builds. So that brings us up to the place where we are today, which is, okay, you've got these inputs, you go through this design life cycle, what are you going to get out of it? And there's a lot of different things you can get out of design. So when I'm speaking specifically around design, what I'm talking about is the stuff that you're actually going to submit as part of a project. Now, there's other things that come from design, checklists, graphics templates, all sorts of things. But those typically aren't submitted as part of a project process. So I'm going to cover the things that are submitted. And the 7 design inputs that I really focus in on are the title page, the legend, the network riser, system drawings, controller drawings, electrical details, and bill of materials. And if you're like trying to write that down as fast as you can, don't worry. In the show notes, I'll have these listed out and you can go and just write them down off that. So go and definitely don't try to take notes while you're driving because I know a lot of you listen to this while you're driving around. So here's the deal, right? Ultimately, a designer is going to submit or going to produce a submittal. But saying, hey, you're producing this submittal is like saying a factory produces things. It's not very descriptive. And oftentimes when you get into this industry, I don't know about you, but for myself, when I first got into this industry, I started on the construction side for a little bit as well as the service side. So I kind of had a blended role and I was expected to do everything because I was working for a small distributor of Allerton and they didn't have a ton of resources to them. So they were like, hey, you've got to be the installer, you got to be the programmer, the designer, the service guy, and the project manager all at once. So it was like drinking from a fire hose for me. And when I first heard that I needed to produce submittals, I had no idea what submittals were. As a matter of fact, I didn't even know what MEP plans and specs were, which, I mean, that's kind of shocking, right? There I am on a project supposed to be leading it, overseeing it, and I didn't know what these things were. But that kind of was the state of the industry, and that, for a large part, is still the state of the industry today, is that you come in, and because we're so shorthanded on people who know what they're doing, just everything kind of gets dumped in your lap and you either succeed and then you move forward, or you're like most folks who end up washing out and you just you can't pick it up fast enough. That's kind of why I created this whole podcast in the first place, was to try to help folks get up to speed faster. So when I first saw a submittal, when I first got asked to produce a submittal, I had no idea. And fortunately, I had a mentor who was like, well, the first thing you got to do is you got to produce, a list of cut sheets and a list of materials that you're going to provide. And that's essentially called a material submittal. That's usually precedes the design submittal that we'll be talking through. But I want to spend a brief moment on that, because what I want you to take out of this is that there's multiple steps in design submittals and the outputs you produce. But at the end of the day, the material submittal and the cut sheet submittal, yeah, they're important. Don't get me wrong. If you go and you provide that, some folks can be real sticklers to that. But if we're honest with each other, where folks really get focused is on the design submittal. So typically what will happen, you'll come on a job and you'll be handed the job, hopefully by the salesperson. They'll do a handoff to you. And then you as the designer, you'll be expected to initially go and provide a list of materials and a list of cut sheets based on what the scope of work was that was submitted to whomever bought the project from you, whoever bought your services for the project. So you're doing that, right? And then that goes through its whole kind of design cycle. I don't see those get rejected. Honestly, the big deal with those is that you want to be conservative on your material estimates so that they don't come back and they're like, well, you said you're going to provide 100 thermostats and you're only providing 25. So, it's those kind of things, those kind of gotchas that you got to look out for. But what really kind of slows down the process, and this is where projects either go really well or projects go really wrong, and it's the actual design. And when I say design, what I'm talking about is the design is a set of documents that is going to show how the system is going to be installed, how the system is going to be operated, how it's going to work, how it's going to be laid out, and it's going to be used by both the installers who are physically running wire and installing and mounting devices. It's going to be used by your programmers and your techs who are going and putting programs into the controls, as well as the techs who are going and then validating those programs. They're going and commissioning, or maybe you would call it startup, or maybe you'd call it configuration. It goes by different terms, but essentially it's, you get a program and it's fairly on point, but it may be a little bit generic. And then you go and you tweak the settings in it. You go and tweak the settings on the controllers. So that is another thing your design is going to be used for. And then finally, your design's all going to be wrapped up into the as-built documentation, which that's as the design was built, hence the name as-built. And that all is going to be wrapped up into a package that then is going to reside with the owner. And this is going to be essentially their O&M, their operations and maintenance documentation. They'll typically call it O&M packages or closeout packages or as-built packages. It goes by a variety of names depending who you're talking to. So now that you see kind of the high level, the big picture, let's dive into design and let's dive into each one of the documents. And I'm going to give you some pointers as to how to have effective design documents. I'm going to kind of go through each one and give you kind of an idea. And this is something I dive much deeper in my design for BAS professionals course, my online training course, but I'm going to give you at least enough that you'll be able to make some good decisions as you move through the design. We won't go into exactly how to create each design and how to create each document, because you can imagine that that's best on video and it takes a lot of time, but we will dive through kind of pointers. All right, so the title page. So the title page, I can imagine you're probably thinking, really, a title page? He's got to tell me about a title page? I mean, like, what can he tell me about a title page? But as I think about it, title pages can be extremely important. And here's why. let's say that 4 years from now, your company is called and they're asked to work on a project that you had installed in the past. And you try to go find the documents that hopefully were stored in some sort of database repository. And you start to look for them and you start to search. Well, what do you search by? Do you search by the job number? Do you search by the name? Do you search by the site? Do you search by the program manager, project manager, designer? Who do you search by? These are all fields. See, whenever you create a title sheet, you need to think about, how am I going to organize my design going forward? Because first off, you really should have a standard about how you organize your past project designs. That way you have a searchable database. Because I've been to I've talked to too many contractors, too many integrators who you ask them for documents on a past job and it's like on somebody's computer who doesn't even work here anymore. And hopefully they got an image before that person left. And it's just kind of craziness. So, some companies will sort by job numbers, some will sort by site name, some will sort by project name. It just depends. You need to decide that. But then once you decide that, you need to think about whatever information you put on that title page is going to be searchable. But you can also go a little bit further. I prefer to use Visio for my drawings. It's a common tool. It's easier to learn, in my opinion, than CAD. And it's just all around, in my opinion, for what we're doing. Since what we're doing is not very architectural, we're not going and changing plans and specs typically. We're just going and creating system diagrams, which we'll get to that in a second. Visio works just fine. And CAD, in my opinion, is overkill. What you're able to do with Visio, and you're able to do this with CAD as well, but what you're able to do with Visio is you're able to add what are called essentially meta information, and that's information about information. So if you were to right click on your file and click properties or click details, depending on what kind of file you have, then you can go and you can add, description, title, tags, all sorts of stuff that then make this document sortable. So when you think about title, it's not just a title page. You also got to think of all the drawings. Like, on all the drawings that you produce, your system drawing, your riser drawing, your controller drawing, do you go and do you have a project number? Do you have a project name? How do you go and make these things sortable? So that is all, in my mind, title information. Yes, you have a title page, but you also have title information that should flow through to all the rest of the documents. That way they're all sortable and organizable. All right, I bet you didn't think we're going to go that deep into title. I bet you're probably thinking, hey, there's not that much to talk about with title. Which then brings us to legend. Now, legends are optional. I've seen companies that had like 4-page legends, and it's like to the point where it's ridiculous. It's like, this is a normally closed set of contacts. I'm like, yeah, okay, folks should probably know what a normally closed set of contacts looks like. Or, this is the symbol for a transformer. I'm like, yeah, people should probably know what the symbol for a transformer is. I mean, kind of common sense here. I get that in some cases you're going to want a legend. Maybe you want to define what color the wire is and how that ties to what type of wire it is. Maybe you say like blue is Ethernet and red is MSTP or power or something like that. The point is, I don't really think you need a dedicated legend. I actually think it creates a pain in the butt for whoever's using the documentation. I mean, think about this, right? You're on a job site, you're on a roof, your hands are dirty, and you're trying to look at the controller diagram, and then you see a symbol, and then you're like, oh crap, I got to go and I got to flip back to the legend, and then I got to compare that symbol to the legend. Versus, in my opinion, legends should be on each page, if necessary. Meaning you don't have to have a legend on each page. I mean, for a network riser, you'll typically have a legend, and it'll describe the power wire, the COM bus, and then the IP bus, and it'll describe what those are. But other than that, I mean, most of this stuff is common sense. If you see something labeled supply fan and it's got a symbol, then You don't need a legend to tell you that that symbol means supply fan because it's labeled frickin' supply fan. I mean, you there's an old saying. Actually, it's not an old saying, but it's from a country comedian, and it goes, "You can't fix stupid." And it's like we try so hard to make everything stupid proof that we go and we overdo it to the point where folks are creating these massive legends. I saw one, I think it was like a 24 by 36 document filled with symbols. And it was, honestly, it was useless because it was just overkill. Your eyes couldn't connect to anything. So that's my thoughts on legends. Put them on each page if necessary, but be careful. I mean, realize that most folks who are looking at these drawings, they've seen these symbols before. And if they don't know what the symbols are, tell them to ask you. It's real simple. Which then brings us to the network riser, right? So network riser is a very important document. And when I say very important document, I don't want to understate how important that is. You know, there's a lot of tips and tricks to the network riser, but the network riser should be able to show you how your physical network is laid out. And what I like to do with the network riser is I like to look at the mechanical plans. I like to look at where things are laid out. And I like to actually get to the point of showing where my COM bus goes from controller to controller to controller. And folks may say that's overkill. And you know what? I get that. That's totally cool if that's what you think. Because I've seen a lot of folks who'll just they'll do floor 1 and they'll do box 10 through box 50. And then they'll say address 20 through 70. Or 30 through 70. And then that's okay. But it's not okay. Because, what folks tend to do is when they do that, they're leaving it at the mercy of the electrical installer, which I get. Okay. I mean, that's the electrical's job, is to go figure out and wire these things up. But you're not telling them what controller has what address. And then what will happen is you'll have this separate set of mechanical plans that will have the controller, and they'll write the address on it in red, and then you need to reconcile that in your as-builts, and it just becomes a big headache because now you're waiting for them to fill that out before you can actually start to go and work on the controllers because you don't know what things are addressed what. So what I prefer to do is actually go and look at the mechanical plans, figure out where the boxes are, where the systems are, and then I figure out what order my controllers are going to go in and how they're going to be wired, and then I number them or address them sequentially. Now, this isn't such a big deal with IP controls, but with field bus controls, BACnet, LAN, etc., you're going to want to go and have some sort of numbering scheme and have some sort of series scheme because these are serial connections, meaning traffic flows in one way for transmit and one way for receive. And by going and laying out, you're going to have shorter trunks because I've seen trunks that run across the building and then back across the building and then back across the building because they just left it at the mercy of whoever was installing it. Versus if you have a predictable trunk run, that's going to make things so much easier to troubleshoot because you're immediately going to know if you see all these things downstream that are offline, you could pretty much figure out what controller is causing the issue. And also, as long as the mechanical plans are somewhat accurate about the placement, then you'll be much faster when it comes to troubleshooting. It'll be a lot easier if you ever have to go and replace a trunk run or replace a controller. You'll know exactly what's going to go offline or online. It's just, in my opinion, that method of going and looking at the plans, laying out your controls, and then sequentially addressing and wiring them and laying that out on the network riser is going to really help your installers. Now, let's turn the page a little bit to IP controls. And this is where things get a little hairy because in the past, it was always, oh crap, we got to go to IT and get a static IP. And now we've got potentially hundreds and hundreds of devices that have IP addresses. And now we're dealing with broadcast domains. We're dealing with subnets. We're dealing with IP addressing, potentially DHCP dynamic addressing. We're dealing with a lot of variables. And if none of that makes sense to you, I encourage you to go check out some of my earlier podcast episodes on IT, as well as look at my IT online training course when it's open. It's closed right now, depending on when you're listening to this. At the time of recording, it's closed. So when that opens up again, I encourage you to take a look at that. But here's the deal. With IP controls, now you're like, how do I lay this out? Because the old plan of laying out the network riser is a little difficult, especially on new construction where they haven't implemented the access layer of the network, or maybe they only have the distribution and the core layer. And if you don't know what those are, they're just like we have supervisory, field controller, and IO to our BAS layers. You have core, and then you have distribution, and then you have access. And those are the three layers. And there's a lot more to that I'm not going to belabor the point with. But here's the deal. So you're going, and now you've got these IP controls, and you're like, how do I lay these things out? You got to you're like, man, what do I do? And my recommendation here is that what you'll typically do is you'll create almost like a spreadsheet. And you'll say, because usually IP controls are going to be in one of three architectures. And once again, I've got an entire episode on IP controls. So just go and refer back to that episode, and it will make things a lot more clear for you. But IP controls have mainly three architectures, actually four architectures. They have wireless, which in that case, that's a whole nother conversation. Then they have IP wired, which direct home run star pattern, which is basically from the switch to the controller, a direct run. Then you have a bus pattern, or a daisy chain pattern, really is what it is. And it just hops from controller to controller. And then you have a ring pattern, where basically it goes to all the controllers, circles back to one port on the switch, and then you have another run that's going to another port on the switch. So basically you have a full closed loop. That way, if one side fails, the other side will communicate. Now, when you're laying out these things, at least with the star and potentially with the daisy chain, you need to understand what port is going to, well, definitely with star, not really with daisy chain. Daisy chain, you only need one port typically for your daisy chain run. You need two ports for essentially your ring architecture. But for star pattern, you need to know, this is fast Ethernet, or this is gigabit Ethernet port 101, and that goes to controller 10, and controller 10's IP address is X. And you need to know these things and define these things. And then now you've got to go and you're like, oh man, I got to deal with DHCP, which is dynamic addressing. Am I doing static addresses to the machines, or am I doing dynamic? That depends on your manufacturer. But you got to start and figure all these things out. Okay, I'm spending way too much time on network riser here. But you can see when you start to get into IP controls, things get a little squirrely. But to tie back to regular controls, your regular serial bus controls, MSTP, things like that, you're just going to go and look at the plans, figure out your route, address sequentially, wire sequentially, and make sure it's represented on the drawing. All right. Then we move on to system drawings. So system drawings are essentially a drawing of the system. Now, I'll be honest. Initially, when I first started creating things, I took the lazy way out. I would go and look at mechanical plans, and I would just copy the system drawing that was in there, and I'd paste it on the control submittals. Now, don't freaking go and put your nose up in the air at me or be like, oh, I can't believe he did that, because I guarantee at least some of you listening have done the exact same thing. But the reality is that is a horrible idea, because just because they're a mechanical contractor and they install this stuff all the day or every day does not mean that it is actually how the system is laid out, and that the placement of sensors and things like that are actually where they need to be. Like, I've seen low temp sensors after the cooling coil, which, think about that for a second, right? The low temp sensor is after the cooling coil. Why do you want the low temp sensor before the cooling coil? So it doesn't freeze the freaking coil, right? Well, if it's after the coil, then is there a potential to freeze the coil, start icing the coil? Well, yeah, there is, right? So these are the things you've got to potentially think about. And so you can't just trust that the placement of the sensors and the layout of the system are correct. Typically on a system drawing, what you'll do is you'll go and you'll actually look up the system. Usually, this is pretty easy with packaged units, but with custom built solutions like custom built air handlers or custom built central plants, this is going to be a little more difficult. But you'll lay out the system and how it works. Then you'll also include the sequence of operations. And this is another one for you. You got to figure out which sequence of operations is correct. Is it the one from the specification or is it the one from the plans? And this is a good RFI moment for you to go and submit a request for information. Because oftentimes you'll get a boilerplate specification, and then you'll get a more granular sequence of operations in the plans because the plans have gone through several revisions, whereas maybe the specification stayed very much boilerplate, meaning standard specification, and hasn't really been customized. I've seen that time and time again. So you'll want to go and make sure that you figure out which sequence of operations is supposed to represent the system operations. And then you'll want to figure out set points, those kind of things. You'll also typically want to put a bill of material, which we'll cover in a little bit, which is basically a list of your material. And you also may want to go and create a points list sometimes, but usually just system drawing and your bill of material, which refers back to the names of the individual systems, the individual devices, and then lists out where they come from. All right, so then we move on to controller drawings. And I've seen really two ways of approaching controller drawings. Controller drawings are where you take a drawing of the controller, its physical inputs and outputs, and then you show, what is connecting to what. And typically on this, you'll have a points list for sure, and you will have a kind of, input 1 connects to zone temperature sensor, or an output 1 connects to fan command. And maybe you'll even have a safety circuit drawing, which basically shows how your different safeties like low temp or high static pressure or low static pressure, how those different safeties are essentially interrupting your command, maybe to your supply fan or maybe to your VFD or whatever, and essentially how that safety circuit should be wired up. So you'll put a lot of that. Now there's two schools of thoughts on control drawings, and I'm going to give you the first school of thought. I'm going to tell you I don't agree with this school of thought, but it's one school of thought. And it's that you keep everything on a single drawing, and that on the control drawing, you actually show how things are going to be wired. So for example, if, input 2 is a 0 to 10 volt humidity sensor that's externally sourced, then you would show, its wiring to the sensor, you'd show what inputs to the sensor, and then you'd show the, transformer providing the external source voltage. I don't believe in doing that. What I believe in doing is method 2, where you actually take what are called electrical details. And an electrical detail, I like this. It's really cool for me because there's only so many ways you can wire things up, and you start to create a library of electrical details. And then what you do is you run essentially your wires from your controller on the drawing to this kind of box, and it references the point name and then the electrical detail. And the electrical details on the very next page, and it'll list out and say, hey, this is the electrical detail, this is how you'd wire this up. And then once you build an electrical detail library, then you can start, and it makes things really fast, and it makes the controller drawing much less confusing. Now, I know earlier I was saying how much of a pain in the butt it is to look at a legend and then look at a drawing. This is a little different though, because usually these drawings are on the same page or on the following page, so you can essentially have two pieces of paper right in front of you, or just do double-sided and just flip the page and look at the drawing and then go right back. And in my experience, this one little change has massively increased the efficiency of electricians because it's super duper clear. Kind of a pro tip here is to actually work with your electricians when you create these electrical details, so that you create the details in a way that the electricians are comfortable. Because the reality is, you're usually going to have 2 or 3, if you don't do install in-house, meaning you don't have in-house electricians, usually you have 2 or 3 subcontractors that you trust and that do most of your jobs. And so if you work with them, you'll create standards that they understand and they know how to work with. So it's pretty cool. Now, I said we're going to talk about the bill of materials. And the bill of materials essentially is a list of materials. It comes from, the old concept of when you would ship stuff, you would have a bill of goods and it would list out everything that was contained in the container. Well, with bill of materials, essentially you're listing out all the different systems or all the different components for the systems on the system drawing. And basically what you do is you'd say, okay, I got this system drawing. It's a rooftop unit. It has a discharge air. It has a actuator. It has a rib relay for fan control. It has an actuator for the cooling and for the outdoor air and return air dampers. Okay, great. And then what you do is you provide that bill of materials on that drawing, so then folks know what part gets installed where, and then they reference the controller drawing to understand how it gets wired up. And then what I like to do is I like to have two bill of materials, right? I have one for the system drawing, but then I have one master bill of materials. And the reason why is if you don't have a master bill of materials, what tends to happen is you don't have a good snapshot of what is actually on the job. Because sometimes in an ideal world, you'll order by system. You'll order all your parts for a system. It'll come in a single box, and that box will be labeled like AHU1, and you'll take that box to the site and give it to the electrician, and it gets installed on AHU1. That's an ideal world. That doesn't always happen, though. And so in that case, what you do is you're going to go and say, hey, I'm going to have this master list of materials so that once I look at what I've ordered, I can then compare it to my master list and start to check off and make sure that I don't underorder or even worse, overorder material. Because, I've seen warehouses full of material because folks overordered material because one guy would order AHU1 stuff and then another guy would order AHU1 stuff, and then now you'd have like 3 sets of AHU1 stuff. Or it would come in different boxes, and so it would get used on a different unit, and then you'd be like, where's the stuff? And you'd be like, oh, I got to order more stuff because I don't have what I need. And the next thing you know, you find it like somewhere in some guy's car, and then now you've got all these duplicate sensors or controllers. And that really can cause a lot of problems on the financial health of your projects. So you really want to try to avoid that. That's why I go and I look at, one bill of materials and then a separate bill of materials. So, these are all common things that you're going to learn as you progress through a career in building automation. It's nothing, some super secret thing. It's just the problem is that a lot of folks are just leaving the field and they're not passing this information on, or folks are just learning really bad habits, and so they're not discovering these things. But the thing is, if you implement these strategies, and these are just a couple, these are just a handful of some of the strategies that I cover in my design course. But if you implement these, you will see massive improvement in your execution, massive improvement in your design effectiveness, and a decrease in the reduction of your submittals. Your projects will just be so much better, and your customers are going to love you because your drawings are going to be very easy to use. They're going to be very good when they finally get handed off. So there you have it, folks, right? Those are the outcomes. Those are the outputs associated with a design. And on certain designs, you'll be more intently focused on certain design deliverables. But if you focus in on these 7 that I just taught you, right, then you will find that your designs they'll be really rock solid. And this is probably outside of IT and like BAS fundamentals. This is one of the skills that is really going to make or break you as you move on in your career. And this is regardless of if you're a technician or an operator or in sales, or if you're an engineer. Having the skill to do design, and no, I'm not saying salespeople should be doing design. No, I'm not saying that operators need to be doing design. But understanding how this is done, it's really going to help you understand the bigger picture, because that bigger picture is just going to make everything else you do so much better. So I really appreciate all of you listening. And if you go to the podcast page at buildingautomationmonthly.com/88, Once again, that's buildingautomationmonthly.com/88. Scroll down and I'll have a little something special for you that you can click. And if you go and sign up for my email list, I will send you this special document, which essentially will be a kind of like almost an infographic of sorts that describes this design process and the different things that happen during the design process. Thanks a ton for listening to the podcast. I really appreciate you being here. Thanks so much. Remember that every day you just do a little bit. Just do a little bit of learning every day. Listen to these podcasts, read articles, take some of the lessons in my courses, and you will be shocked at how massively your knowledge is increased, and as a benefit, as a side effect of that knowledge increasing, you'll see your career increase. And that will be absolutely awesome. So thanks a ton for listening. Take care. I'll talk to you in the next episode.